Okay, so I chose problem 2 from the 2021 FRQ to solve. So the question is, for time where t is greater than 0, a particle moves in an xy plane with position xt, yt, and velocity vector is given. At time t equals 0, the position of the particle is -2 and 5. So the first question is, find the speed of the particle at time t equals 1.2. So, and then the second is find the acceleration vector. So to find speed, they already gave us the velocity vector, so we can just plug it into the equation derived from the Pythagoras theorem, where we use the dx dt squared plus dy dt squared, because we already know the velocity vector to find speed. And this was a calculator section. So what you do is you plug in t minus 1 et squared, and you square it, and you get 0.84414 squared, and then this is dx over dt, and then dy dt squared equals sine t 1.25 and squared, which you get 0.95085 squared. So then you do the overall square root of 0.84414 squared plus 0.95085 squared, and you get 1.271. And this was all at time t equals 1.2. So in the calculator, make sure you get the value at t equals 1.2. So that was the first part. The second part is find the acceleration vector of the particle at time t equals 1.2. So remember that you have your calculator given to you. So what you can do is do n deriv in your calculator at t equals 1.2. So you get d squared x dt equals 6.247, and d squared y dt equals 0.405. Because to find an acceleration vector, you're taking the derivative of velocity vector. So in n deriv, you get the derivative at time t equals 1.2. The derivative at time t equals 1.2 from the velocity vector, so which is what we need. So then the acceleration vector, make sure you write it in the proper acceleration vector form, 0.405. So this is A, and you get 1 point for speed and 1 point for acceleration. So it's pretty good. I'm hoping that's what we get points for. So the next question is B. Find the total distance traveled by the particle over the time interval 0 to 1.2. So to find total distance, we're given velocity vector. So what we can do is take the integral of the velocity vector from time 0 to 1.2, and we'll find the total distance. So now we're working backwards. So 0 to 1.2 square root dx over dt squared plus dy dt squared equals, we can use our calculator for this. So you get 1.00 if you round it up, it's 1.010. So that's the total distance from time t equals 0 to t equals 1.2. So that's how you do B. And then C is a little trickier. Find the coordinates of the point at which the particle is furthest to the left, for t is greater than 0. Explain why there's no point at which particle is furthest to the right, for t greater than or equal to 0. So for C, it's asking for a particle furthest to the left, but the value of t has to be greater than 0. So to find furthest to the left, we have to first find dx of dt equals 0, because we need to find a minimum to see when x is the smallest, because if x is the smallest, it's going to be more to the left because it's like negative. So dx dt equals 0 at time t equals 1, because t minus 1 et squared. So when t is 1, 1 minus 1, so 0 times et squared equals 0. So at time t equals 1, dx over the vector, velocity vector, is 0, which means that dx dt changes because there's a 0 at the velocity vector. That means that the position function would change from negative to positive, because if you plug in values a little bit bigger than 1 and a little bit smaller than 1, you get negative to positive at t equals 1. Also, it's also important to know that at xt there is a relative min, because it's going from negative to positive. So obviously there's a relative min at t equals 1. But the main point is since this is the only critical point, because there is no other values where dx dt equals 0 except for t equals 1, this is also at t equals 1, xt has an absolute minimum. And absolute minimum is the furthest left the point will get. So now that we know it's t equals 1 is where xt gets its absolute minimum, we can now plug it into the equation to find the coordinates, because that's what the question asks you, the position. So x at 1, so they gave you x equals 0, so you'll have to do integral of 0 to 1 x prime of t from the velocity vector, and you get negative 2.604, and then you'll have to do that for y. They give you y0, which is 5. Is it 5? Yes. And negative 2 for x, plus 0, 1, y prime of t dt equals 5.410. So the position equals negative 2.604, 5.410. Now, there's a little bit of the question still left. It's asking you explain why there's no point at which the particle is furthest to the right for any value where t is greater than 0. That's true because since dx dt is greater than 0 for t greater than 1. So we know that when t equals 1, dx dt is 0, but dx dt is positive after t equals 1, which means the particle moves right. Moves right for all t greater than 1. Therefore, there is no point furthest to the right because it just keeps going right. So you don't have like a point where it's like the furthest to the right, because that makes no sense because it's keep going right. So yeah, that's the problem. And yeah, I hope you guys enjoyed.